Okay, we're going to work again. This is on day 4 of simplifying radicals. We're going to start, and there's going to be an additional way or thing that we have to do. But let's start with the beginning, the basics here. Okay, come on, pen. There we go. All right. Right here, what's different than what we've done the last 3 days? They have letters in there, right? This is the same as the square root of 40 and the square root of b squared. Okay, b squared means that there's 2 b's, right? How many does it take to get out the house? 2. Okay, so on the b's, it takes 2 to get out of the house. So how many b? So now I get to take a b out of the house. Does that make sense? So now you take and do the 40. There's a couple different ways. I was showing you guys how to go through and simplify it all the way down to your prime factors. But what if we did 40 like this? 4 times 10. And the reason why I did 4 was because 4 is a perfect square. See, I could take the square root of 4 and the square root of 10. What is the square root of 4? 2. 10 breaks up into 2 and 5. It can't go any lower. So my answer would be 2b square root of 10. Let's look at another one. Actually, let me do this instead. I've got this one. They've added a couple others in different ways, but I want to start just with this. All right. So what if I have the square root of 45 b squared c? All right, let's look at all of this separately. When we have something like this, let's look at the square root of 45, and then you can look at the letters. B squared times c. Okay? If I start with 45, one of the things you can do is try and figure out those perfect squares, which one goes into it. See, perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9. One of the other teachers here, she tells you to write, the Geometry K teacher tells you to write all the perfect squares over here to the side, because that'll help you look at them and try and figure out, see, 49, 64. All right. Out of these perfect squares, which one, can you see one that multiplies in to get 45? 9. See, I can take 45 and I can split it up into 9 times 5. Okay, well, what's the square root? We have the square root of 9 and the square root of 5. What's the square root of 9? 3. Does 5, the square root of 5, can you do anything else with that? No. So I'm going to leave a square root sign and leave the 5 in there. Now the letters. This means b squared means that there's 2 of them, and then there's 1 c. It takes 2 to come out the house. So a b comes out, and what's grounded and has to stay inside the house? The c. This would be your simplified form. Let me go back a second on this one over here. All right, now, I'll do this. This one right here, there's a fraction underneath the square root sign, right? Let's apply it to the top and then to the bottom. So it means I'm going to have the square root of 5 over the square root of 16. Can the square root of 5 simplify? No, it has to stay square root of 5. What about the square root of 16? What's the square root of 16? It is 4. This would be your answer right here. Those of you taking notes, that's a good thing. All right, so let's look at, where we go here? There we go. Try this one right here. It says a square root of 180 divided by 9. Now I know what they want us to do. They want us to take the square root of 180 and then the square root of 9. But here's the thing. Does 180 divide into 9? What's 180 divided by 9? 20. So I would, if you could, divide this first. That's 20. So I'm going to have the square root of 20. Now I can simplify 20. Is there a perfect square that goes into 20? Remember, perfect squares. 1, 4, 9, 16. Do any of those go into it? 4 does. 4 times 5. So now I'm going to have the square root of 4 and the square root of 5. What is the square root of 4? 2. So my answer is going to be 2 square root of 5. So what about this one? 3 square root of 20. We just found what square root of 20 was, right? Didn't we just find that square root of 20 was 2 square root of 5? Right? That's what we did over here. Well, now we have 3 is already on the outside. Now we have times 2 square root of 5. So what does that become? 6 square root of 5. That would be what my answer would be. Let me move on down here. Take a minute and try and do these 3. Take a minute and try and do these 3. All right, on the first one that says 60, x to the 4th. First thing you're going to do is try and find the square root of 60, and then you're going to do the square root of x to the 4th. Square root of 60. You can go to break these down into prime numbers, but I'm going to try and do perfect squares. Does anybody know a perfect square that goes into 60? Did anybody find that? 1, 4, 9. 9 doesn't go into it. 4 does, right? Somebody do 60 divided by 4. 15. Okay, so 60 is 4 times 15. So now I have the square root of 4 and the square root of 15. So now, square root of 4 is 2, and then I leave square root of 15 in there. X to the 4th. 1, 2, 3, 4. How many come out? I have 1 that comes out. I have another. So that is x squared. If you think about it the short way, see it says x to the 4th? Divide it by 2, and then that's what comes out here. This one up here, square root of 27 and the square root of 64. Square root of 27 over the square root of 64. Are either of those very easy looking at it right off the top? What's the square root of 64? 8. So on the bottom, it already goes to 8. So now I just have to look at the square root of 27. Is there a perfect square that goes into that? 3 and 9. So I'm going to have the square root of 9 and the square root of 3. What's the square root of 9? 3. So it's going to be 3 square root of 3. This is your answer. That's as simple as it will go. See, after you do this, you would have to look and see, like, if this 3 was actually a 2, you would reduce the 2 over 8. But I can't do anything anymore with this. Down here. All right. When I go through to do this, I've got x to the 7th. 1, 2, 3, 4, 5, 6, 7. I've got y squared, which is 2y's, and then I got z to the 16th. Now, this is why I'm saying if you can figure it out without having to write them all out, it makes it easier. If you write them all out, you can still circle 2 and bring them out, circle 2 and bring them out. But with what I was trying to show you, oops, let me give myself room. Let me make my house. What is 7 divided by 2? Does it go in evenly? how many sets of 2 goes in there? So if you took 2 times 3, you get 6, right? So I can pull out x to the third. Then how many's left over? 1, so I'll leave a 1 inside the house. If I take 2 divided by 2, what do I get? 1, so I have 1y. I guess I need to move this over. All right, too big. What's 16 divided by 2? 8. Z to the 8th. See, if you're wondering where this 1x came from that stayed inside there, look here. Take 2, pull it out. Take 2, pull it out. Take 2, pull it out. There's my 1, 2, 3. There's my x to the 3. The 1x is still chilling underneath here. All right, here's the thing though. When you are simplifying radicals, the radicand has no perfect squares left. Okay, what does those big words mean? Please remember, the radicand, it's the number that's underneath here. What is underneath the square root sign is called the radicand. It cannot have any perfect squares left underneath there. The radicand can have no fractions. You cannot have the square root of 2 over 5. And we're going to talk about that in a minute. But this is a no-no. You cannot have any fractions. There are no radicals. This is the big one down here. There cannot be any radicals in the denominator. So if I use this one right here, square root of 2 over 5, and I did square root of 2 over the square root of 5, this cannot happen. You cannot have any radicals in the denominator. So then the question is, well, what can I do? How can I get rid of it? So let's look at that. This is called rationalizing the denominator. Right now on your paper, write rationalizing the denominator. I cannot have a radical in the bottom. So what I can do is multiply this by 1 and fix it. But you're like, what do you mean multiply it by 1? If I multiply this by the square root of 3 over the square root of 3, anytime you multiply and you have this, like the same number divided by itself, that's 1. So the point to this is 2 times the square root of 3 becomes 2 square root of 3 over. Now, square root of 3 and square root of 3. What that does is it leaves 2 of them underneath the square root sign. 2 come out the house. So the reason why we do this is so that now my number just becomes the denominator. I am moving the radical to the top. Can I reduce 2 divided by 3? Or is that as low as it goes? That's as low as it goes. That's your answer. So what about this right here? What would I need to multiply it by to get rid of my radical sign? I'm going to multiply it by that radical down in the bottom. So I have square root of 2 divided by the square root of 2. So now, I have 5 square root of 2. And now, what did I just say? When you multiply these together right here, it just becomes that number. That's as low as it can go because 5 divided by 2 does not work out evenly, and I cannot reduce that anymore. All right, here are 2 for you to try. Try these 2. All right, so looking at the first one up here, those of you who are doing what you're supposed to, I appreciate it because it'll make a difference right here. What you should have done is multiplied by that bottom number, square root of 5. Now, as you go across the top, I have 3 square root of 5 over. When you multiply these together, all it does is become 5. And that's it. That's your answer right there. But you can't leave a radical in the denominator. That's why you must multiply by it. So the next one, down here. All right, so we go through and we multiplied. You should have multiplied the top and the bottom by the square root of 7. Now, there's a 2 outside, so I leave it as a 2. These are underneath the square root sign. So you have to take 3 times 7, which gives you the square root of 21, over square root of 7 becomes just a 7. Is there any perfect square that's in 21? There's nothing, because I can't do anything else with it. You have to leave it like that. 2 divided by 7 does not go any lower. That's your answer. If there is a perfect square, then you do have to pull out the perfect square and keep working from there. Now, here is how you're going to see it used in applications like with geometry and stuff like that. All right, it says find the area, and what they're going to tell you is leave in the simplest form. There's only a couple of these. There's only 2, I believe. But in algebra, or in geometry, you cannot leave it with a decimal as an answer. Now, what I know is I've got a right triangle right here. Actually, that doesn't matter, the right triangle. It says find the area. What's the formula for the area of a triangle? Area is base times height divided by 2. Now, when this bottom length, this is my base, from here to here is 3. I need the whole base. What is that? Should be 6. So my base is going to be 6. I need to find my height, though. This is my height. So now, because it's a right triangle, I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. Which number is C? C is the number across from the right angle, so that would be 7 squared. 3 is one of the legs, and it doesn't matter which one you use, so I'm going to do 3 squared plus, you can use B squared or X squared, I don't care which. So now, I don't have my calculator pulled up, so I need you guys to do this. What is 7 squared? So what is that? I have 49, and you have to move that over here. 49 minus 9, so that's going to be 40, right? So x squared is 40. Now to find x, you need to take the square root of 40. Now the square root of 40, you need to reduce it. Is there a perfect square in there? 4 times 10. Square root of 4, square root of 10. It is 2 square root of 10. That's my height. That's what this is. You don't get to use a decimal. So it's 2 square root of 10. Now, we did all that work so that we can put it into this formula. Area equals base times height. 6 times 2 square root of 10 divided by 2. What is 6 times 2? It is 12. I get 12 square root of 10 divided by 2. This is why I was saying it depended what was, if they could divide or reduce. What is 12 divided by 2? 6. My answer, the area is 6 square root of 10. Right here. That's your answer. You don't get a decimal. They want it in a square root. All right, so what about this one? It says find the area. So the area, the formula for area is base times height divided by 2. What is my base and what is my height? Do we have one of those? I'm speaking to y'all. Do we have one of those? What do we have, the base or the height? We have the base of 9. I need to find the height. It is a right triangle. A squared plus B squared equals C squared. What number is C? Right here, across from the hypotenuse. That one is C. So I'm going to make this 9 squared plus x squared equals 12 squared. 9 squared is 81 plus x squared equals 144. That's 12 squared. Subtract 81 from each side. X squared equals, what's 144 minus 81? Help me out there. 63? Okay, so now x is the square root of 63. But there's a perfect square hiding in there. What perfect square is hiding in there? 9. This is 9 times 7. So the square root of 9, the square root of 7. I get 3 square root of 7. Now put it in the formula for your area. Base 9 times 3 square root of 7. Base times height divided by 2. 9 times 3 is what? 27. Square root of 7 all over 2. Does 27 divided by 2, does that reduce? Does it work out nicely? No. So that would be your answer for the area.